Have you ever felt the earth shaking? Yes, it's nothing but an earthquake. An earthquake is a shaking or tremor of the surface of the earth resulting from the sudden release of energy in the earth's lithosphere. Before going more into detail, we need to understand what causes an earthquake. The earth has four major layers: the inner core, outer core, mantle, and the crust. The crust and top of the mantle make up a thin skin, which is the surface of our planet. But this skin is not one piece. These are puzzle pieces which keep moving slowly, sliding past one another, bumping into one another. We call these puzzle pieces tectonic plates, and the edges of the plates are called plate boundaries. The plate boundaries are made up of many faults, and most of the earthquakes around the world occur in these faults. There are seven major plates: African plate, Antarctic plate, Eurasian plate, Indo-Australian plate, Pacific, and the South American plate. Types of plate boundaries: divergent boundary, plates moving apart. It creates ridges. It is known as a constructive plate boundary, example Mid-Atlantic Ridge. Convergent boundary, plates coming together. This results in the creation of mountain fold belts as the rocks are forced to move upwards, example the Himalayas. Transform boundary, plates moving past each other. This creates shallow depths. It is normally dominated by the strike-slip faulting, example the San Andreas Fault. But how does the earth shake? When the edges of the fault stuck together and the rest of the block is moving, the energy that would normally cause the blocks to move is being stored up. When the force of the moving block finally overcomes the friction, it unsticks and all the energy is released. The energy radiates outward from the fault in all directions in the form of seismic waves like the ripples in the pond and shake the earth as they move through it. Scientists measure the earthquake through seismograph, and the recording that they make is called seismogram. You might have noticed news articles writing about the place of the earthquake, but how it can be identified. Seismograms come in handy for locating earthquakes. Being able to see P and S waves is very important to determine how it shakes the ground. P is so fast than S waves that help us to determine where the earthquake was. For better understanding, let's compare it with thunder and lightning. During a storm, we see the lightning, then hear the sound, because light travels faster. Similarly, P are just like the lightning and S just like the thunder. The P travels so fast and shake the ground, then S follows. If you are close to earthquake, P and S waves will come together. But if you are far away, then there will be more time between the two. By looking at the amount of time, scientists can tell how far the earthquake was from that place. They use a method called triangulation to determine exact place of the earthquake. Effects: although earthquake causes a lot of damage and destruction, it also leads to the formation of various landforms. The largest earthquake ever recorded was a magnitude of 9.5 in Chile in May 22, 1960. It triggered a tsunami causing an economic damage of $4.8 billion and killed almost 1,600 people. Do you know the longest earthquake ever recorded lasted for 10 minutes? Animals can predict earthquake just prior to it since they behave very unusually. That's all for today. Keep loving Geo and bye.